Greetings, students. Let's discuss practice test 3-4. Question 1. The interior angle of a regular polygon. Around your answer, find each interior angle. So remember, we do 180 times the number of triangles. So there's 13 triangles in a 15-gon, 2 less than the number of sides. So 180 times 13 is 2340. That's the angle sum. We divide that by 15 to get each angle individually. Now remember, there's 15 angles, but there's 13 triangles. So what's happening here, some of you is you're not remembering both things. 15 angles, but 13 triangles. So 2340 divided by 15, 156 degrees, which is the interior angle, each interior angle of a 15-gon. Alright, exterior angles are always equal to 360 total. So if we take 360 divided by 13, we're going to get the exterior angle of a 13-gon, which is about 27 and 7/10 when it rounds. Alright, next thing, a parallelogram. Adjacent angles are supplementary. So I'll take 11x minus 3 plus 73. That's going to make, we're adding this, 11x plus 70, and it will be equal to 180. So take 70 from 180, you'll get 110. Divide 110 by 11, you'll get 10. Value of x here is 10. Alright, the diagonals are equal on a parallelogram. This CE is the full diagonal. XE is only half of one. So what I'll have to do is either divide CE in half, or I'll either have to divide CE in half or double XE, and then they'll be equal, because XE is only half of CE. So I can set 2x equal to 16, or I can set 4x equal to 32 to get the finished answer of x equals 8. Alright, next thing, trapezoid mid-segment theorem. The mid-segment is the average of the two bases, top and bottom bases. So here, what I'll do is I'll take 4 plus x. I'll set this equal to half of 7 plus 9. That's 16, which is 8. Half of 16 is 8. 4 plus x is equal to 8. X is 4. Now when it's backwards like this, instead of taking the top and bottom and dividing by 2, I will double the mid-segment, and it'll be equal to the top and bottom just added together. So here I'll take 12x plus 5 plus 17. That's 12x plus 22. This will equal not 35, but 70. 35 times 2. And now it's 70 again because the mid-segment is half of the sum of the bases. So if I double the mid-segment, it becomes the sum of the bases. Like I could times this and make it 8 plus 2x equals 16, and I get the same answer. Anyway, so it's easier to double the mid-segment here than it is to cut in half the sum of the bases, which I could do. It would be 6x plus 11 equals 35. Anyhow, 22 from 70 is 48. And 48 divided by 12 is 4, which is my answer. Alright, next thing, trapezoids. These two angles are supplementary because they are same side interior, consecutive interior. So I'll take 6x plus 27, I'll add in the 99, I'll get 16 and 12. 6x plus 126, it'll equal 180. 126 from 180 is 54. X is 8, 9. Sorry, I said 8. That'd be 48. Alright, SU and TV are equal here because the diagonals on a parallelogram or trapezoid are congruent. So 2x minus 6 will equal 12. Adding 6 to 12, we get 18. Dividing 18 by 2, we get 9. Value of x is 9. Pythagorean theorem. This is looking for a leg, so we're going to subtract. 12.5 squared minus 6.1 squared will equal, this is where calculator comes in, 12.5 squared minus 6 1/10 squared is 119, about. I'm going to square root it to get my answer. And it's 0.04, so I'll keep the decimal there. The square root's above the squared key on the calculator. So make sure you can find it properly. It's about 10 9/10. Alright, determine if it's a right triangle, obtuse, or cute. So let's add the sides squared and see what that makes. 9 squared plus 9 squared. 9 squared plus 9 squared makes 162. Let's see what the longest side squared makes. 15 squared is 225. So because the hypotenuse is bigger, this will be obtuse. The hypotenuse is bigger when it's squared. If the legs were bigger, it would be acute. And if it was equal, these two numbers would be right triangle. Anyway, so we got 10 questions on the front, 10 on the back. So this is 50 points, 5 points each. Right on the back here, we got the SOHCAHTOA. I've got it on the board. SOHCAHTOA. So here, find the missing side lengths. Oh, this isn't SOHCAHTOA, this is the unit triangle, sorry. SOHCAHTOA is next. So here is the unit triangles. We got them on the board. The base triangle has lengths of 1, 1, and the square root of 2. So how many times bigger is this one than the base? The base triangle has, of course, the 45, one of the corners. So this is a 4 instead of a 1. So in other words, this triangle is 4 times larger because it's 4 instead of 1. It's 4 times larger, meaning that y is 4, 1 times 4, and x is 4 root 2. 4 times 4 root 2. Alright, this one is my 30, 60, 90 triangle. So my regular 30, 60, 90 has a 1, a 2, and a square root of 3 with the 30 here. So this is my hypotenuse. How many times bigger is this one than 2? Well, it's 2.5 times bigger because 2.5 times 2 is 5. You could also say it as, well, 5 divided by 2, 2.5 times bigger. So this is 2.5 times bigger, meaning that B is 2.5 and A is 2.5 times the square root of 3. Unit triangles. Alright, next one is SOHCAHTOA. SOHCAHTOA. So tangent is opposite adjacent, O and A. Opposite divided by adjacent. So Z, the opposite from Z is 3, the adjacent is 4, 3/4. Remember, the hypotenuse is always the longest. So 5 is not adjacent because it's the hypotenuse. 4 is adjacent, since it's not the hypotenuse and it's next to Z. Opposite is across from. Alright, the sine is opposite over hypotenuse. So the opposite from A is 10. The hypotenuse here is the longest side, 26. 10 over 26. If we want to reduce it, we can make it 5 and 13. Alright, here we're using SOHCAHTOA as well. You have to determine which ratio to use to solve the triangle. This should be sine, because we have opposite and hypotenuse from the 64. So the sine of 64 is equal to x over 16. Times 16 by the sine of 64, you'll get your answer. 16 sin 64. 16 sin 64. 14.4. Here we're going to use tangent. Tangent of 32 is equal to 20 divided by x. Switch the x into 20, or tangent 32, sorry. So x is equal to 20 divided by tangent 32. 20 divided by tan 32. It's about 32. That is coincidence that it's the same number as the angle. Now, if you want to use lost signs here, you can use lost signs as well. X over the sine 64 is equal to 16 over the sine of 90. You get the same answer. X over the sine of, this would be 48, because they make 180 total, equals 20 over the sine of 32. You can use lost signs here as well, if you'd like. So that's where the lost signs is applicable on this test. You can use it to find these angles as well, these sides as well. Alright, angle measures. You can use lost signs here if you want, but we're supposed to be using SOHCAHTOA. It's the easier way. So the tangent of this angle is 14 over 23. So x is the arctan of 14 over 23. So I'll just type in arctan, second tan, 14 divided by 23. About 31 degrees. And here we're going to use sine, because we had opposite hypotenuse. Sine of x is equal to 5 over 13. X is the arcsine of 5/13. Arcsine of 5 divided by 13. About 23 degrees. Again, for these questions, if you want to use the lost signs, that's perfectly fine. You would say the sine of x over 14 is equal to the sine of 90, and you need to find this side of the Pythagorean theorem. Let's use lost signs here. Here I'd say the sine of x over 5 equals the sine of 90 over 13. So it's possible to use lost signs on all four of these. If you want to use lost signs instead of using SOHCAHTOA. SOHCAHTOA is just the faster method. Alright, find the missing length. X is in the middle, so x over 9. On this small triangle, x is the long side, not the hypotenuse, but the long side. 9 is the short side. On this one, though, 16 is the long side, and x is the short side, so it should be set up like this. So x squared is equal to 16 times 9. We're going to multiply diagonally, in other words. So 16 times 9, 144. X is 12. We're not going to use the negative root here, so only positive 12 is the answer. If you want to get question 20 right, study question 10 on page 64. It'll be pretty much the same question. So if you want to get this one right, open up your notebooks, study question 10 on page 64. 50 points on the back as well. Good luck. Hope we do well.